Let us study about fundamental forces in nature. There is a link between technology and physics, and here some examples are given. On the left side, we have technology. On the right hand side, we have scientific principles on which they are based upon. Like we have steam engine which is based upon laws of thermodynamics. We have nuclear reactor which is based upon controlled nuclear fission. We have radio and television which are based upon generation, propagation, and detection of electromagnetic waves. We have computers which are based upon digital logic. We have lasers which are based upon light amplification by stimulated emission of radiation. Production of ultra-high magnetic fields are based upon superconductivity. Rocket propulsion is based upon Newton's laws of motion. Electric generator is based on Faraday's laws of electromagnetic induction. Hydroelectric power is based upon conversion of gravitational potential energy into electrical energy. Aeroplane is based upon Bernoulli's principle in fluid dynamics. Particle accelerators are based on motion of charged particles in electromagnetic fields. Sonar is based on reflection of ultrasonic waves. Optical fibers are based on total internal reflection of light. Non-reflecting coatings are based on thin film optical interference. Electronic microscope is based on wave nature of electrons. Photocell is based on photoelectric effect. Fusion test reactor, which is also known as tokamak, is based on magnetic confinement of plasma. Giant meter wave radio telescope is based on detection of cosmic radio waves. Bose-Einstein condensate is based on trapping and cooling of atoms by laser beams and magnetic fields. The gravitational force is the force of mutual attraction between any two objects by the virtue of their masses. A very good example of gravitational force is the Earth-Moon system. The Moon revolves around Earth due to gravitational force. Electromagnetic force is the force between charged particles. Let us understand Coulomb's law. Let us consider 2-point charges Q1 and Q2. Let's consider distance between Q1 and Q2 to be r. Then by Coulomb's law, force between these two charges is directly proportional to modulus of Q1 and Q2, and force is inversely proportional to distance square. Coulomb's force is inversely proportional to the square of distance between the two charges. So we have two equations, and combining both of them we get force is proportional to Q1 Q2 by r square. Scalar form of force is written as F equals K into Q1 Q2 by r square, where F is the magnitude of force, K is proportionality constant and denoted by 1 by 4 pi epsilon naught. Then Coulomb's law is written as 1 by 4 pi epsilon naught into Q1 Q2 by r square. Epsilon naught is called the permittivity of free space. The value of epsilon naught in SI units is 8.854 into 10 raised to the power minus 12 c square n raised to the power minus 1 m raised to the power minus 2. Note that wherever we have written Q1, Q2 in the equation of force above, we have written it inside a modulus sign. Thus, we always get a positive value of force by this formula. But actually, we write the Q1, Q2 along with their signs. For example, for a minus sign, we write minus Q1, and for a positive force, we write plus Q1. Thus, when we get this force as a negative value, it means the force is of attraction, and when we get a positive value, the force is of repulsion. Now let's move on to another force, which is called strong nuclear force. The strong nuclear force binds protons and neutrons in a nucleus. It is evident that without some attractive force, a nucleus will be unstable due to the electric repulsion between its protons. The nuclear force is the strongest of all fundamental forces, about 1000 times the electromagnetic force in strength. It is charge independent and acts equally between a proton and a proton, a neutron and a neutron, and a proton and a neutron. Let us study about another force. This is called the weak nuclear force. The weak nuclear force appears only in certain nuclear processes, such as the beta decay of a nucleus. In beta decay, the nucleus emits an electron and an uncharged particle called neutrino. In the diagram below, we have some radioactive element, and alpha radiation, gamma radiation, and beta radiation are shown emitting out of it. The weak nuclear force is not as weak as the gravitational force, but much weaker than the strong nuclear and electromagnetic forces. The range of weak nuclear force is exceedingly small, of the order of 10 raised to the power minus 16 meters. The experimental discoveries of Ørsted and Faraday showed that electric and magnetic phenomena are in general inseparable. Here we have a tabular comparison of different forces. In the first column, we have name of the force. In the second column, we have its relative strength with respect to strong nuclear force. In the third column, we have its range, and in the fourth column, we have the area where it operates. So the first one is gravitational force. Its relative strength is of the order 10 raised to the power minus 39. Its range is infinite, and it operates on all objects in the universe. Weak nuclear force is of relative strength 10 raised to the power minus 13. Its range is very short, that is subnuclear size, approximately equal to 10 raised to the power minus 16 meters. This particularly acts between electrons. It operates in some elementary particles and neutrino. The electromagnetic force is of relative strength 10 raised to the power minus 2. Its range is also infinite, and it operates among charged particles. Strong nuclear force has a relative strength of 1 because we are comparing the relative strengths with strong nuclear force itself. Its range is short, which is nuclear size, around 10 raised to the power minus 15 meters, and it acts on nucleons and heavier elementary particles.